Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To Doctor and to our fellow friends, my name is Muhammad Amirul Aiman bin Nurizan from Group 8. Okay, so now we will present to you guys about our full with bridge rectifier circuit where we do it in the TinkerCAD. So first and foremost, we need to have a generator where we fix it. The frequency is 50 Hz, our amplitude is 10 volt, our DC offset is 0 volt, and our functions is our sine because we want our graph in the oscilloscope is in the sine graph. So and then we have a oscilloscope where it will give the display of our graph. So this is a voltage versus time. Where we can see here the voltage is x axis and the time is y axis. So we fix the time per deviation is 5 millisecond. And then we have a four diode because we want a full wave bridge rectifier circuit. We have like this four diode here that maintain as a rectifier for our circuit, and then we have a cap with this resistor, and then we have a capacitance where it's act as a filter, where we make it the capacitance is 5 microfarad, and then we have a Zener diode and a pair with a resistor where the resistor is 1 kilo ohm and the xenon diode is 200 millivolt, where it has a voltage regulator. So we will see the simulation first to give you a point of view for our circuit here. So we can see here that the generator here give a display to our oscilloscope that have a AC voltage there. So we can see that there has a full wave AC voltage input, and then I will present to you guys about the flow of the current in the circuit. So the flow in current circuit is we first take the positive and it's in a positive region, and then negative is in the negative region. So the flow is we will go here first to the diode 1 because diode 2 because it is in a in is in a forward bias, so it will move to the resistor first and then the capacitance, and then it's go to the Zener diode because it is in the what I want to say the parallel, so it will go back to our uh line in here and then move to our diode 4, yeah, diode 4 here. So and then go back to the generator, the negative. So here we can see that it will not move to our diode 3 and our diode 5 because it's in the reverse bias. And then we will take from the negative side, where the AC is from moving from plus minus and change to minus plus. So move to here, and then we can see that it will go to the diode 3 because it is in the forward bias. The forward bias we will go to this resistor and then the capacitance, and then to our Zener diode, and go back to our diode here, which is the diode one here, where it move from this side to diode first and then go back to our generator, which is positive. So we can see that we have AC graph, and then we have a ripple graph, which is the filter output voltage, and then our DC output voltage. So I will explain to you guys what about is the rectifier, the filter, and the voltage regulator, where the rectifier is act as a it will rectify the AC voltage input to something become a DC voltage, where the negative half cycle of the AC voltage will be inverted, so just to have a positive voltage at the output. So we can see there the just a positive output here because the rectifier have made it to the top and make the graph at the positive cycle, just in the positive cycle. Yeah. So and then we will go to our capacitor where it acts as a filter. So the purpose of the filter is to remove the fluctuation in the voltage output. So we'll produce a smoother DC voltage output. And then the capacitor, we can see here we have a ripple voltage. This is because the discharge or to eliminate all the component AC component. So we can see that this is a ripple here. Yeah. And then we move to our Zener diode, which is act as a voltage regulator. So voltage regulator is uh the purpose is to make our voltage outputs become more in a linear where it's maintain the voltage output until the end. Okay, so now you have a crystal clear view of our circuit here, and I hope you guys understand the full wave bridge rectifier circuit after this. All right, thank you.